Hello, my name is Victor Escarate-Cruz. I've been tasked with the design and implementation of the fuel cell for our project. We're team number 18, KAIKANA. We are one of the teams chosen to develop a power source for a hypothesized lander alongside NASA's mission to Psyche. Psyche is an asteroid in the asteroid belt between the orbits of Mars and Jupiter. It is an exposed nickel-iron core of an early planet, possibly a failed formation of a planet during the early years of the solar system. It is made of 30 to 60% iron. It has a gravitational pull of about 0.144 meters per second squared. And it is also 3 astronomical units, that is, 3 distances from the sun to the earth away from the sun. We've discussed different power generation techniques for Psyche, such as solar, RTG, and different types of fuel cells. We concluded that solar energy would probably be the best solution, although because it is 3 astronomical units away, it would be too large of a solar panel in order to incorporate enough power to the system. We decided fuel cell generation would be the best option for our set amount of time.
Hi, I'm Sean Caldwell, and I'm interested in the circuitry and controls of our design. As we do more research on the power needs of different instruments, we will decide whether our solution is acceptable. Currently, our goal is to provide constant power to multiple instruments for 100 hours. We will provide a peak voltage of 65 to 100 volts with the possibility of a peak power of 50 kilowatts for larger equipment like thrusters. And for that, we are considering the integration of a supercapacitor to handle the large current draws. We will design a power management system that will efficiently step voltage down with 12, 5, and 3.3 volt outputs.
Hi, this is Robert Smith, and I'll be in charge of the instrumentation and controls of this project. For our lander, we will have 2 temperature probes, where one will be used to acquire surface temperature fluctuations and the other as feedback for our fuel cell thermal management system. Secondly, we are including a Gauss meter and an ultrasonic sensor to relate the magnetic field to the distance from the asteroid. A microcontroller will be utilized to record, process, and transmit the data. These instruments will require 12 volt and 300 milliamp or combined 4 watts each. The power needs of the communication system and the microcontroller will require further calculation as we decide on an acceptable sampling and transmission frequency.
Hello, how's it going, everyone? My name is John. I'm from Team KAIKANA. One of the components we expect to add on for controls is thermal regulation for the power management system. Psyche 16 has a 4-hour day compared to Earth, with the expected temperature ranging from 100 to 250 degrees Kelvin, roughly equating to -9 to -280 degrees. The temperatures are frigid. Retaining thermal energy will be a priority as we take this under consideration. As surface temperature will fluctuate, an ideal would be to utilize Planck's law and Stefan Boltzmann's law by measuring the energy over the waveband. We are unsure and would like to explore if heat is retained, and if so, how much it radiates. We will employ a thermosensor to evaluate to increase or decrease the temperature of our system. A plant model will need to be contrived to evaluate the sensor limits for finer adjustments. As design and tested goals are met, we'll make a comparative analysis to evaluate and adjust to reach our 100-hour goal. As always, mahalo nui loa. Aloha.